Hey there, and welcome. Today, we're going to tackle one of the coolest ways to think about patterns in math, recursive formulas. You know when you see a string of numbers and you're like, wait, what's the rule here? Well, if that's you, you are in exactly the right place.
This quote right here, this is basically the secret key to this whole thing. Recursive formulas are all about using the information you already have, the step you were just on, to figure out the very next step. It's a step-by-step process, and that simple idea is going to be our guide today.
So, what are we really talking about here? I want you to think of a recursive formula as a mathematical scavenger hunt. It's not going to give you a big map showing the final treasure right away. Nope. Instead, it gives you one clue that leads you to the next spot, and then that clue leads you to the next one. Okay, so here's the official definition you'll find in a textbook. It defines each term using the one that came right before it. But honestly, just keep that scavenger hunt idea in your head. It's way more intuitive. You use the previous clue to find the next one. Simple as that.
Now, any good scavenger hunt needs two critical things, and it's the same for our formulas. First, you absolutely positively have to know your starting point. Where does the whole thing begin? And second, you need the rule. How do you get from where you are now to the next step? If you're missing either one of these, the whole thing falls apart.
Okay, let's dive into the notation, because I get it. The symbols can look a little intimidating at first glance. But I promise you, once we translate it into plain English, it's actually super straightforward. We're just going to break down what each little piece is saying. On screen, you can see the two main players in any recursive formula. You've got a sub n. Just think of this as today. It's the term you're trying to find right now. Then you have a sub n minus 1. That's simply the term that came right before it. The easiest way to remember this? Just call it yesterday. That's it. The formula uses yesterday's value to find today's value.
So when you put it all together, the formula recipe reads just like this. In English, it's saying, to get today's number, take yesterday's number and add d. And what's d? Well, that's just the common difference. That's the number you're adding or subtracting over and over again to get from one step to the next.
All right, enough theory. The absolute best way to understand this stuff is to see it in action. So let's roll up our sleeves and apply what we've just learned to a couple of classic examples.
Let's start with this sequence, 7, 10, 13, 16, and it just keeps going. Our job is to write down the scavenger hunt instructions, that recursive formula that perfectly describes this pattern.
And we just follow our simple two-step process. Step 1, find the start. Well, the first term, a sub 1, is 7. Easy. Step 2, find the rule. What are we doing each time? We're just adding 3. So our common difference, d, is 3. Put those two pieces together, and boom, you've got your complete formula. Okay, now for something really fun. Let's flip the script. This time, we're given the instructions. Our job is to just follow the clues and find the first 4 terms of the sequence they create. The instructions tell us our starting point is 20. So that's our first term. Done. The rule says to get the next term, we take the previous one and subtract 5. So for term 2, we take 20, subtract 5, and get 15. For term 3, we take yesterday's number, 15, subtract 5, and get 10. You see how it works? And here's the final move. We take our third term, 10, follow that rule one last time, and subtract 5. And our fourth term is 5. See? It's just simple, step-by-step logic.
So, why does any of this matter? What's the point? Let's take a look at a couple of common pitfalls, and then see how this whole idea actually shows up in the real world.
All right, listen up, because these are the 2 biggest mistakes people make. First, they forget to state the starting point. Just writing the rule isn't enough. Where does the scavenger hunt even begin? You have to include your starting term. Second, remember, this method is fantastic for finding the very next term, but it's really terrible for finding a term way down the line. It's built for small steps, not for giant leaps. So here's the kicker. You've probably already used this kind of thinking without even knowing it. For real. If you've ever used a spreadsheet like Excel or Google Sheets and dragged a formula down a column, you are literally using a recursive process. Each new cell looks at the one right before it, at yesterday's value, and applies a rule. Pretty cool, right? And all this leaves us with one final big question. We know recursive formulas are awesome for finding the next step in a pattern, but what if you needed to take a giant leap? What if you wanted to know the 100th term without having to do 99 separate calculations to get there? Well, that's a puzzle for another time. Thanks for joining me.